All right, welcome back. So here we have the practice problems that you were supposed to do on your own. Let's go ahead and go through them together. So number one is a power to a power property. When I have something in parentheses, power to a power, I multiply the exponents together. So this is 4 to the 2 times 3, or 4 to the 6th power. And 4 to the 6th power, if you want to finish that off, is 4,096. Number 2, notice I have negative 8 times negative 8 to the 3rd power. Recognize that this is negative 8 to the 1st power because I have no exponent there, so that's what would be 1. This gives me a product property. So when I multiply the bases together, I add the exponents. Excuse me, I did this wrong. That's a to the m times a to the n. So I can add these together, and I get negative 8 to the 4th. And then negative 8 to the 4th, I can just do that. And it turns out it's the same answer as the second one, 4,096. Finally, the last one here. Here's our quotient property. We can reduce this to 2 to the 3rd over 9 to the 3rd. Because this exponent on the outside goes to both numerator and denominator. That's going to give me 8 over 729 as my final solution. Now, I cannot subtract these because the bases are not the same. So I can't use my quotient rule because the bases are not the same. This would have to be a 2 and a 2 or a 9 and a 9 in the base in order to subtract the exponents. So 8 over 729 is my final answer. All right, and that's those examples. If you had an issue with those, please make sure that you call me over and ask for help. We can go over them together. But if you're okay, let's go ahead and move on to the next set of examples. Where, again, we're using the properties here, but we're just using them with a bunch of different exponent expressions. Okay, so let's just go ahead and start on number A. We have b to the negative 4 times b to the 6th times b to the 7th. That looks like a product property to me. Since I'm multiplying things together, that tells me that I can add the exponents. So really, this is just b to the negative 4 plus 6 plus 7. And adding those together, you get b to the 9th. Right? So multiplying things together, I add the exponents. B, I've got a couple of things that I can do here, right? I've got a quotient rule that I can do. I've also got a power of quotients here. I'm going to go ahead and do the quotient rule first. These bases are the same, which means I can subtract the exponents. So this is r to the negative 2 minus 3, which gives me r to the negative 5, and that's being taken to the negative 3 power. Now my power of a power property tells me that I multiply these two numbers together to get r to the 15th. And that's that. And again, we can do this a different way. We could go r to the negative 2 to the negative 3 power over r cubed to the negative 3 power. And then when we simplify these would be multiplying. Let's draw a line here. These are separate examples. This would be r to the 6th over r to the negative 9th. But that's r to the 6 minus negative 9, which is r to the 15th, right? So no matter which order we do that, we do end up with the same solution. Okay, let's do C. So here we have 16 divided by 2, and notice we've got two different variables this time. When we're dealing with two different variables and constants here, what you're going to do is just do them all separately. So here we're going to do the 16 divided by 2, and then this is m to the 4th divided by, well, there's no other m's, so that's 1. And then this is going to be n to the negative 5 divided by n to the negative 5. So what do we get when that happens? Well, this is 8, 16 divided by 2, because those are just whole numbers, right? The m to the 4th divided by 1, that just stays m to the 4th. And n to the negative 5 divided by n to the negative 5, well, the division rule tells me to subtract these, which gives me n to the 0. And what does our 0 property say? Anything to the 0th property is always equal to 1. So this is 8 times 1 times m to the 4th, and then 8 times 1 just makes 8. So final answer, 8 times m to the 4th. Let's do a couple more. We got 2 more examples here to do. So look at D. We have a to the 4th, b to the negative 5th, c squared to the negative 4 power. Again, I've got multiple variables going on here. We can do this 2 different ways. I can take everything to the negative 4th power first, or I can handle the negative exponent first. I think what I'm going to go ahead and do is do everything to the negative 4th power. So again, this is our power of a power property, which says when I'm multiplying things inside the parentheses, everything that's being multiplied gets taken to that power. This is a to the 4th to the negative 4th times b to the negative 5th to the negative 4th times c squared to the negative 4th. Power to a power tells me to multiply, so this is a to the negative 16th times b to the 20th times c to the negative 8. And everything looks really good here, but I've got these negative exponents that I've got to deal with. The a to the negative 16th becomes 1 over a to the 16th. The b to the 20th stays in the numerator. Notice how I'm putting it over 1. And the c to the negative 8, that's going to move down to the denominator. Again, negative exponents make a reciprocal. So final answer here, when I multiply these together, is b to the 20th, because that's 1 times b to the 20th times 1, over a to the 16th, c to the 8th. Notice how all the negatives do is move that into the denominator. They just moved it down. All right. Last one. I'm multiplying these 2 things together. Notice that this really is just an a to the m times b to the n, or a to the n kind of thing, where I'm just going to be multiplying what I can together. Since this is all multiplying, this is w to the negative 3 times w to the 7 times v squared times v to the negative 5. Multiplying the variables tells me to add the exponents. So this is w to the 4th, and this is v to the negative 3rd. Finally, since these are different bases, I don't combine them. I just have to deal with the negative exponent. And the negative exponent flips it, right? Reciprocal. 1 over v to the negative 3rd. So final answer is w to the 4th over v to the 3rd. And I'm sorry, that should be positive, not negative. Negative exponents make reciprocals, okay? All right, there's a couple last examples for you to do on your own, so please go do those. Check out the last video to see those solutions, and then there will be an assignment for you on Canvas. So we will see you in a couple minutes.